Okay, hello everyone. Welcome to the India Cloud Security Summit 2021. Our next session is presented by Karl Ots, and Karl will be speaking to us about the top pitfalls of Microsoft Azure security and how to avoid them. So welcome, Karl, and take it away.
Perfect. Thanks, Jason. Good evening, good morning, good afternoon, wherever you are. I presume for most of you it's quite late in the evening already. So you made it. This is the end of the conference. This is the last session. You survived so far. So now you've earned to have a little bit of fun with me with this quite randy and quite energetic session. First of all, thanks a lot for all of the sponsors for supporting this event. It really wouldn't be possible to organize all of this, and especially all of the volunteers on the conference organizing side as well. So let's have a look at this session. Top pitfalls of Azure security and how to avoid them. And this is really my favorite type of session, and really favorite type of session format as well. It's ranty, it can go on and on, it has war stories, it has very specific advice, not just FUD, so it's great, But first of all, who am I? So my name is Karl Ots. I'm a head of cloud security at EPAM Systems, which is a global consultancy. People all over the world, including in India, a couple of thousand as well. I wear many different hats as a community leader. I'm also a conference organizer and a user group organizer myself. I'm one of the puppet masters behind the Global Azure set of events, and I also host the Cloud Gossip Cloud Gossip podcast, and I'm an MVP and a Microsoft RD as well. Very recently, or even looking a little bit towards the future, I'm also the author of Azure Security Handbook. Personally, my first book that I'm very proud to have worked through the pandemic to actually publish a book. So not the easiest journey, and it's going to be out mid-September in actual physical books, but also as ebook as well. And check it out. All right. So let's really start looking at cloud security in general, and it's actually quite common to a common misconception that actually cloud security happens because of there is that much more footprint and that much more attack vectors for our attackers. But actually, the reality is based on the actual data that we can gather. The latest data that we have, here's an example from Verizon data breach report from last year. In 2020, data breaches were actually most likely to happen because of misconfigured public cloud services rather than external attacks or application vulnerabilities or any other topics that they list. They have, I think, roughly 15 to 20 different categories that they evolve a little bit over time. So actually, the number one way of getting yourself into the list of successfully breached application or organization or anything like that, getting yourself to the headlines is to misconfigure your public cloud services. So having run into or falling into some of these pitfalls or failing somehow your cloud security on either very specifically with a very small part on your application or something fundamental across your whole environment. And this is actually something that even Gartner has to kind of constantly keep on telling everyone that actually nearly all of these successful attacks to any sort of environments on the cloud are results of us, the customers who are using the cloud, doing something wrong, not understanding how we are using the cloud, configuring something in a way that it's not supposed to, leaving maybe some services in their defaults, maybe not using all of the latest bells and whistles or the most expensive tiers with the best security built in, etc. It's not necessarily something that these mega vendors on the cloud will be misconfiguring. Well, as we know from yesterday's announcement regarding Cosmos DB, sometimes it's also true that the big league groups are also a little bit misconfiguring on their own, but most often the most typical one, the one that you actually need to worry that is in your pay grade, is really all about configuring your cloud services properly. And yeah, so let's start looking at this. Where are these types of misconfigurations? What are they? And more specifically, what you can do to actually avoid these kind of most common pitfalls regarding this cloud security, so that your name won't be on the list of these heads falling in these most vulnerable clients and applications. Great. First one should be easy. We all know. Excuse me. We all know, or we should know, that unprotected public endpoints are, even by the very nature of the cloud, they should be the top one issue there. It's effectively all of our applications, all of our data center just connected to the internet. So by default, that sounds like a bad idea. And what do we mean by bad idea? Here's an example of I have actually two virtual machines that I've ran for 24 hours, so just a single day. It's default latest Windows servers with everything patched. I've taken this from the Windows or actually the Azure Marketplace, the latest Windows images by Microsoft. They're not even at their defaults. They're actually somewhat hardened and all of that, but by default they are actually open. So here's an example of failed login attempts. I'm querying from all of these logs from 24 hours from 2 machines. How many failed logins do I have? And at first look, you actually see that. Let me actually highlight this for you for the sake of the recording as well. So we'll see that actually we have roughly 3,000 different records of logs in here. But actually these 3,000 are actually different types, or excuse me, there are different usernames that have been tried to actually sign in a failed sign-ins. So this is not actually 3,000 attempts. This is 3,000 different usernames. And as we start seeing these first usernames, admin, administrator, different spellings, different languages, you actually see that there are thousands per individual usernames. Well, luckily for us, with these default images and the default way of creating VMs in Azure, these first ones are not our issue, because if you haven't lifted and shifted a VM there, we won't be able to use even these default usernames like user, admin, root, etc. in Azure. So somewhat better than it could be, but still the exposure is, whenever we do something wrong, everyone will hear about it and they will immediately start poking holes in our environments. And this is, if you think, okay, I'm doing cloud, so I don't necessarily need to do virtual machines. Well, think again. Whenever you are dealing with something that you are responsible of actually managing the network side of thing, then you are actually responsible of the network altogether. Here's an example of Azure container instances. I have a sample application here that I pulled up, and this is actually, if you have a look at it, it's roughly 5 hours of data, where we have 5 hours of logs of this container application running in here, and this is even worse. We see Nmap scanning, we see application scanning, we see different attempts at trying to poke holes into our possible APIs that we might be hosting in there. This is a Wild West. This is not just failed brute force login attempt. This is actively querying and trying to understand our application. And this is 5 hours of uptime of this particular container. Think about it. Are you really sure that in your environment you don't have any servers, any containers that have public endpoints available? And yeah, think again. Most likely you'll need to find out how to fix them, and that's why we're talking about it. So first of all, anytime you are managing yourself a public IP address in Azure, whenever you have an IP address resource on Azure with a type of public, it is a set of risks that you are introducing to your environment. You should really be carefully thinking about, can I actually use some sort of a Microsoft managed software as a service, platform as a service environment to actually protect myself against this? Maybe put different controls in place. If you are dealing with virtual machines and infrastructure as a service environments, you should at the very least start putting on network security groups when you are dealing with Azure. You can put this access control list in. You can use application security groups to group those together. You can use service tags to kind of make your life a little bit easier. At the very least, use these network security groups. If you need to actually manage your VMs in there, then you need to put in place some sort of ways for you to actually access those virtual machines. Built-in version in Azure with the cost comes with the just-in-time access as part of Security Center that actually opens up a dynamic network security group rule for you for a pre-specified amount of time. So you can open up your connectivity, you'll get access to the VM, and after 4 hours, 8 hours, whatever you have defined or your admin has defined, the access or the network security group is actually turned back off. Well, if you are still connected for a while, actually your NSG rules will not actually get observed, or they won't. The NSG rule engine won't actually evaluate because there's no incoming request from you from the same IP address. So your connection will stay open. If you have SSH, if you have RDP, that connection will stay there for a while, depending on the protocol, of course. So not that optimal, but still better than just leaving everything open. Azure Bastion, great example of an browser-based environment where to manage that. Not always the best because of some limitations on your own side. You might not be able to do everything that you can on browser, but if you can, Azure Bastion, very easy to set up nowadays, supports peering of VNets. You can actually have one single bastion across your environment. Pretty neat, if I say so myself. And on an Azure Platform as a Service side of things, it can kind of split into different parts. If you are working on data services, so if you're using Platform as a Service and components from Azure, storing your data there, like let's say Cosmos DB, let's say storage account, let's say Azure SQL, etc., you can actually start putting in place service endpoint rules. You can put in place private endpoints. You can even have this quote unquote firewall where you can list IP address rules, not just service endpoint rules, but actually IP address rules or VNet rules for you. And yeah, if you really can bear the cost of private link, definitely you can put in private endpoints there in place as well, so that no data exfiltration is possible on your environments there. And yeah, on the compute side of things, again, from the data exfiltration, definitely makes sense to look at private links so that your environments won't be able to talk outside. Here's an example. Here's a couple of examples on the container as a service, platform as a service side. You can think of having this private AKS cluster. It actually comes with private link for the nodes and actually has these the API server that you use to manage, which is where you connect using your kubectl, which is where you connect if you open up to your AKS cluster in the portal. You can actually have this API server authorize IP ranges also for that as well. So even if someone gets access to your keys for your AKS cluster, you can still limit who can call those API servers there. And Azure App Service has nowadays very decent private link support and even some quite nifty virtual netting there as well. So it's actually pretty neat for you to actually able to enforce so that your outgoing data will always go through a specific set of addresses or through a specific virtual network. But again, private link could be costly and could be very, very complex. Couple of examples from the data side of things. Here's an Azure storage account. I've set up a virtual network firewall rule. And I also have here highlighted this allow trusted, or if I'm able to highlight, there's an off by one error there, definitely for the rows. There is this allow trusted Microsoft services to access this storage account. Now, this is something that enables us to use services that are connecting, that are coming from not our own networks, but actually these shared networks, such as Azure Backup or these other services that Microsoft handles for us. Which services these are vary. we have various, some services support Azure DevOps, some do not. Some services have very limited amount of services, such as Azure Defender very recently came available and inside this set of exceptions here as well. And likewise, if you are dealing with an application where you are hosting some sort of data in Azure Storage account and actually need to provide your clients access there, most likely you will need to deal with create some sort of a valet key pattern based way of sharing that content using SS tokens or something else. Whenever you are creating those SS tokens to actually grant single time or time limited use of access to that data in your blob storage, even if it's by default secured from the network and access control perspective, these SS2 tokens can overrule them. So be aware when you're sharing them. Whenever you share it away from your application, then it's potentially can be free distributed. You don't know. You can enforce HTTPS only. You can actually create, when you're creating them, you can actually assign an allow list of IP addresses so that even if someone gets their hands on the key or this SS token, you can actually still enforce that this key, this SS token can only be used from within a certain IP address or IP address range specifically. Great additional layer of control in there for you. Perfect. Next, misconfiguration, pitfall, fail, however you want to call it, would be broken authorization. And really, I mean broken, not misconfigured or misunderstood or anything like that. Really, really broken. By default, every user in Azure is an owner. Whenever you create a new subscription, you'll be the owner, the new person, new developer, whatever your team colleague comes in. When you don't know what access to give them, you will be giving them an owner, and that's how it kind of spirals out of control. And really, it is in the subscription scope of everything. And what's wrong with that? Well, owner is really the default role for any sort of new services. If there is no custom role available for the service that you are using, owner is the one that can do everything in there. It can manage user access. It can create and manage keys. It can have, in a lot of cases, can have access to data. It can invite anyone in. It can invite new users in, and by default, depending on, of course, on your configuration of your Azure AD tenant, by default, you can actually invite any external users, not even any Azure AD users, but anyone with an email address actually in. So that's not cool. So what should we do? Well, role-based access control means that everyone should have appropriate access based on the role that they are doing, not unique list of access that would accumulate across the time that you are working on that environment, but based on the role that you are working on. So it means that we need to have separation of duties. That's what it is. So the owner role, this can actually be split into two roles. The contributor role that most of us know, it's basically something that acts as a super admin without these user access management capabilities. So a contributor can do most anything within the Azure environment. They can create resource groups if it's a subscription level. They can create resources inside those. They can delete firewalls. They can create costs. They can delete services, etc., etc. So if you want to have a lot of empowerment for your team, if you as a developer want to ask the maximum access, don't ask for the owner. The default role for you should be maximum contributor. I know it sounds very humble. Contributor is like, I'm just contributor, I'm helping to it. It doesn't sound like how powerful it actually is. But trust me, it is enough for most of your work. And whenever you actually need access control changes, whenever you actually need something else that the contributor doesn't have, that's where the user access administrator comes in. It's a built-in role. It's been there for a long time, but because it's not on the top 3 list of owner contributor reader before the whole list of being in alphabetical order, a lot of people don't even know about it. So the user access administrator, as the name says, it can create, it can manage this access control. It has access to this authorization range, but it cannot write anything to the actual resources. So it cannot create databases. It can delete firewalls. It cannot move resource groups or anything like that. But it's not that simple. I already mentioned briefly that actually some services on the data side of things, some services actually allow you to go ahead and modify your authorization rules as a contributor as well. So for most of the platform as a service data services in Azure, I've listed SQL, storage, and Key Vault here. But Cosmos DB is a good example as just like these others. For all of these services, contributors should be considered actually as privileged role as owner, because in practice, as a contributor, I can go into the storage account, I can regenerate the keys, I can get this admin key, account key, and do anything within the data. I can as an contributor, I can actually go inside the SQL database. I can change who is the server admin there, and then I can do anything in there. As a contributor, I can go to the Azure Key Vault and I can change the access control rules. Again, I can invite anyone. At least for the Key Vault, it always has to be anyone within who has an entity in the home Azure Active Directory tenant. So you can't just give someone a magic key, static key that can then do anything with the Key Vault. You will need some privileged access on the Azure AD side of things to be able to work with create a service principal and then add that here. That's what happened with the Solorigate, of course. Luckily, we now have proper data plane RBAC coming for all of these services. We have for storage, we have for Key Vault, we have for SQL, proper role-based access control available. You don't always need to use these old school authorization providers that can be overridden with contributor. However, unfortunately, not all of them are as mature yet that you can actually enforce those. SQL only very recently came out with the capability in preview to be able to enforce so that there isn't this manual SQL user in there. So still a little bit room to go, but at least this is something that you can configure and audit at scale to see at least the very baseline where you're at. So that part was about which sort of appropriate role to give you, what sort of authorization to have. And the other part of RBAC, of course, is the scope. And role-based access control assignments are inherited. So if you get the subscription level assignment, it will have access to any resource group and any resource and any SQL database that you're ever going to get created by you or anyone else inside that Azure subscription. And same goes with the different hierarchies, management groups, etc. So you should really minimize these subscription scope assignments altogether. If you recall, the default was owner and owner actually in subscription level. You shouldn't have owners and you shouldn't have them. You should have direct assignments in the subscription level. You should go with resource groups, resource group level, preferably owner, preferably contributor, excuse me, or if you're using services like privileged identity management in Azure or other ways of just-in-time access or elevating your access when needed, then you could have, for example, owner roles also available, eligible for those resource group level roles as well. All right, and go ahead, and if you come up with a question, comment regarding any of these topics during my session, go ahead and type them into the chat. I'll be going through those at the end of the session, but of course at the end you can always ask those questions at that point as well. Good. Let's move over to the next topic, which is audit logging. And really the pitfall is actually having none, completely missing audit logging. And if you are thinking of checklists such as OWASP, they talk about insufficient audit logging. Here, I really mean missing audit logging altogether. Most of the Azure services don't actually by default emit any type of audit logs by default. They might be available. There might be some available, or even for it depends a little bit on the service, but when you turn them on, you might get access to a little bit of backward history, but typically you're not in luck. You need to do this before you actually need your logs. And sadly, this is true even for services where you will really expect to have these logs on. Azure Key Vault, a way for securely managing access, and management includes auditing who has had access, who has used the access to our secrets, to our best certificates, to our encryption keys, to our most secret data in our organization. Azure Key Vault does not create you these logs by default. You need to go turn them on. Azure Web Application Firewall. Azure Web Application Firewall does not create any logs by default. Go figure. So you need to go ahead and turn this on. These are changing a little bit. Microsoft is trying to consolidate everything together. You should start seeing them as resource logs in the new Azure Monitor speak, which means that for all of your services where you will need to turn your logs on, so most of your services in prod at least, you should find them under the diagnostic setting, and underneath the diagnostic setting you can create it by selecting the resource specific log. Azure Key Vault provides us access logs and performance logs. I would select access logs in here. Sorry, in this screenshot, it was still called audit event type of a log. I will select the type of the log. I would select where do I want to store them, where it is a storage account and an event hub if I want to get it away to my CM or to my external SOC, or perhaps my on-premises where I store everything, or internally to Azure if I want to store them directly to a log analytics workspace. So I select what type of a log do I want and where do I want to store it. And that's what I need to do for all of the services. I can do this automatically with Azure Policy, but the actual type of log changes based on the service that you are using. And when we have these logs on, someone should have a look at them, right? But we can actually automate this part as well. So because there is now suddenly so much noise and so much signals, we can actually use Azure Defender to actually automatically send us alerts and kind of do a little bit of noise filtering and prioritization based on the type of data available on these logs or from these logs. This is a paid service for each of the services that it supports. So it depends a little bit on what type of service you are using. If you are using Azure Storage Account, you have these type of different Azure Defender alerts available for you. You get notified when there is some sort of new or at all anonymous access. You get notified when someone changes access permissions using those account keys, when there is some sort of data exploration or data exfiltration type of activities happening. Someone using a key that hasn't been used for a long time, some sort of anomaly on that type of usage, accessing from somewhere that you don't usually use them. And this is great insight for you, and especially I've worked with some of the largest organizations here on the planet. When you have to deal with thousands of subscriptions and countless of storage accounts or different services across those subscriptions, you really need some filters, some automated alerts that then you can actually consume yourself in your SIEM environments. And here's an example of an Azure Defender alert for Key Vault. As you can see, here's an alert related to unusual operation pattern. There's a specific type of a user, specific. Let me highlight it here. So specific type of a user account has been used. Some sort of Karl sounds very suspicious. Started to use some activities called unwrapping keys, getting the whole vault data, and actually authenticating altogether as well. So this seems suspicious enough to alert, and this is what Azure Defender had done for us. All right. And there are also other types of alerts that we can raise based on our either custom work, not just data from Azure Defender, which are kind of predefined sets of rules, and we just have them, all of them per service, or none of them. And here's an example of something very specific that I've set up using Azure activity logs, which are available all the time. These are not logs from individual services, but are activities from the Azure Resource Management. And here someone went ahead and listed the storage account keys. You see this is a custom log because you'll see there's a typo in the name of the log alert as well. Activity logs are available for 3 months. So 90 days for us, it's not best, but as a default setting, it's okay. As you might know, most attackers have been in your environment for over 200 days, depending a little bit on industry and who you ask, etc., and the type of attack. But most often it's more than those 90 days, but it's still something that you have available for you in your tool set in your toolbox of tools for this insufficient and missing audit logging. And finally, a last one here's an example from Azure Application Insight. And Azure Application Insight actually can create these availability tests and availability alerts and other types of automated or machine learning alerts that consume the logs from the web application that you are hosting and compare that statistically from the experience before. So in this example, I got an alert that this particular get campaign index request is typically running 1,000 times faster than now. This is the normal response time, less than a second. Now it's almost 9 seconds. So something really needs to be wrong. As you'll see, it even is telling me that this is not impacting actually everyone. It's actually impacting only roughly 15% of all of our users. So this is really something that could have to do with a potential attacker, or maybe just a weird performance bug, but definitely worth looking at with human eyes as well. All right, and we talked about authorization earlier, but something very specific related to these legacy or ways of accessing outside of Azure Active Directory, which we talked about a little bit, is that actually when you are using, for example, Azure Storage Account, these access keys, these are really this type of super keys that when used, they can create, read, update any sort of data inside that storage account. And we actually don't get logs who has used those keys. We only get access to the data. We only get access to, okay, now these keys were used. And historically, if we happen to have had those activity logs on, we could go ahead and look back, see who ran this storage accounts list keys action, and potentially look at all of the people who have ever done that and see maybe it has to be one of those people. Preferably, you could actually even restrict usage of this action altogether. You can actually turn this off on your new storage accounts, if your applications support that. You might have your applications, or you might use third-party applications that actually really rely on these account keys. So you will need to see how your migration goes with these activities, but there is a possibility for you to go towards using these data plane role-based access control roles instead of these legacy access keys, these static keys altogether. And there you go. Here's a big button that this is the magic button that you should have if you have the luxury of actually disabling this. I called it an account key earlier. In some documentation, it was master key. In this, it's supposedly shared key. It's all the same. It's that one account key, as you can see in the screenshot. Actually, it's the same access key that is listed in here. This is the shared key that they are using as terminology. So this is not SAS shared access shared application signature key. This is the account key for the whole storage account that can let you do everything. You can disable it if your application supports that. If you're working on a new environment, definitely enforce this across all of your storage accounts so that you wouldn't need to deal with this. It will take you a while based on your existing footprint, but trust me, you will thank me later. I mentioned also that third-party applications might not support this, but you might not consider, for example, Azure Cloud Shell or AZ Copy as third-party applications. But bear in mind, if you disable this, your Cloud Shell won't work. Any kind of legacy implementation against Azure Storage Account won't work. All right. Earlier I mentioned when regarding the authorization that quite often the default setting actually regarding authentication providers allows you to invite anyone into your environment. And what do I mean by that? By default, again, a misconfiguration that you can have. If you don't do anything, this is what happens. You are using untrusted authentication providers. It can be an external Azure AD. It can be a complete rogue Azure AD that someone created from your environment even, but doesn't have any configuration or logs in place. It can be a Gmail account. It can be a Microsoft private account. It can be basically anyone with an email address, basically. And I've seen this happen in different types of environments where, especially if we are dealing with more limited environments for the Azure Active Directory tenant, then if you haven't blocked actually creating new Azure Active Directories, then your developer or you as a developer can actually go in, create a new Azure AD tenant. You will be the global admin there. Then you can add any users, you can create any service principals, and then you could link your environments, web applications, whatever you are using against that authentication provider or against that Azure AD. Don't do that. And from the enterprise perspective, you should block creating new Azure Active Directory tenants always. Well, how to mitigate this? Standardized using your Azure Active Directory in your web applications, in your data plane, Microsoft Platform as a Service assignments. Always use Azure AD authentication instead of this key-based authentication or any other auth that you might think of. Azure Active Directory PIM that I mentioned earlier for managing privileged access can actually be used very well for alerting and auditing any sort of privileged access control. Also, not just for the Azure roles, but also for Azure Active Directory as well. And if you are working from a centralized role perspective, if you are a security architect, if you are a tenant admin, etc., you can think of starting to limit and control these Azure AD guest invites by the users. You might have a completely separate process of inviting those users in, and you should configure your Azure AD accordingly. Here's a couple of examples that show you what you can do. And just a sec. Let me walk you through a couple of them. Admins and users in the guest inviter role can invite. So either you need to be a privileged role, either you need to be a global admin, or you need to have a specific guest inviter role in order to invite. Sounds great. By default, these others are on. Members can invite, even guests might be able to invite. These are all settings that you should talk with your enterprise IT, you should talk with your Azure AD team, you should talk with your IAM in order to see what works best for your environment. At best, you could actually even limit these all together and actually start seeing if you can actually restrict even more specifically, not just who can invite, but also who can be invited. You can maybe even have a list of specifically allowed onboarded partners, for example, that you double check from your IAM system in order to allow invitations for those guests. And here's an example of a benefit that happens when you are actually using Azure Active Directory as an authentication provider for your web applications. I can actually go in as a centralized admin. I don't need to learn how you specifically on your environment if you even have created any access logs. I can go into my Azure Active Directory application sign-in logs. I can check the activity in here. I can see different Karls logging in over here into the same demo1 application. I can see that there were even a failed conditional access that happened in here. I can go ahead and see what happened in there. Were they not part of the real group that they were supposed to? Did they fail MFA? Were there some other conditions? Maybe it's a user who was logging in from somewhere that they don't usually do. Everything I have, both the good and bad logins, all of those, if I'm using the centralized way for the Azure Active Directory, I can actually see even for my applications themselves in my Azure Active Directory app sign-in logs, not all in overall Azure Active Directory sign-in logs, but application-specific sign-in logs. And then we can do nice things like this. Here's an example where I can use Azure Active Directory throughout the end-to-end application. I have my application users logging in through Azure Active Directory to my web application. The conditional access check where I can add different rules regarding which sort of endpoints or which sort of network environments do they need to come from. I can use Azure Active Directory managed identity to assign access from the web application to the SQL database. So again, no keys in there, nothing to lose. And again, I can actually have access. I can access private binary files, also in my storage account, again using managed identities. And if I need to have other type of access for any sort of developers outside of users of this application, I can actually grant them directly the users as data plane RBAC roles, not with some sort of an account key that could be again stolen or misused. And that pretty much wraps it. I have a call to action for everyone. So most of these things can be centrally checked using the tool of your choice. They can still be checked by something called a secured DevOps kit for Azure or HZSK. HZSK is a tool, a PowerShell-based tool that you can use to scan your environment against Microsoft best practices. It's great from a centralized perspective because you can run it across your whole environment, or you can scan it against your very specific access. You need to have reader to your Azure environment, and that's it. If you have reader to resource group, then it just runs it for the whole resource group. And if you are a tenant management group user access admin, then you can run it against the whole tenant. Here's a quick example how it looks like for you. It creates both log exports. You can export them to whatever logging system you're using, or if you want to do this manually one by one, you can use the export to CSV functionality there. Unfortunately, Microsoft deprecated this summer. Microsoft deprecated Secure DevOps Kit for Azure. This was not a Microsoft product group or Azure product group product or a service. It was actually built by Microsoft core service or engineering, or just Microsoft IT, and it was somewhat competing with Security Center and other native Azure security services. So it is officially no longer supported. It is officially deprecated. You can still use the rules, but if something breaks, you're on your own, and there won't be any new rules added. It's available in hzsk.azurewebsites.net. There is a replacement built by native services, Azure policies, etc., called Azure Tenant Security Scan, AZTSS. It's built by the same team, so the same rules are there, etc. And actually, you can go ahead and check in this third link that I have in the github.com hzsk DevOps Kit policies. In here, you can actually go ahead and have custom policies custom Azure security policies that perform the same logic and same tests as the AZSK did. So you can still leverage that same insight. It's a little bit different way of enabling though. And finally, the way to look at any upcoming, any future changes, I recommend you to look at Azure Security Benchmark, which provides you with best practices and recommendations to help improve the security of your services. There's an ASB Azure Security Baseline documentation for each Azure service. And actually, since February this year, actually the default Security Center policy initiative that you have, the default list of things that Azure Security Center checks, is actually based on this Azure Security Benchmark. So that's pretty good news and good initiative from Microsoft in both the technical security initiative and both the organizational initiative that they are actually doing that. And finally, if you want to compare what is inside a specific initiative or a policy, I really recommend you use this Agent Advertiser tool. It's a great tool to find out the differences and if there is an availability for a policy that is covering your specific scenario. It is not an official Microsoft product. It is built by a Microsoft employee, but on their own time, and there's no support as such, but it's a great tool for your governance and security exploration work. All right, a couple of next things on this. So I'm also a LinkedIn Learning author. If you want to learn a little bit more on this, send me a message on LinkedIn. I'll send you a 24-hour usage for my course. You can check it out for free. And as I mentioned, the security handbook is coming up in September. Go ahead and check this out as well in a physical or digital environment as you would like. And then I believe we have a survey coming up. So yes, Jason has also pasted the Microsoft Forms in here as well with the same code that you'll see over here. Please fill it up. And if you haven't done so for your earlier sessions, you should have still access in your team's history to those as well. This is really appreciated, and there are even some, I believe, some prizes involved as well. All right, with that, I am wrapping up from my side. I'm very happy to see a lot of you still coming. What is it? 10, 11 o'clock for some of you, and yeah, if you have any questions, I'm still available here for the next 10 minutes or however. I think we are the last session, so we can still, if there's questions, we can still keep it going for a while.
I don't see any questions yet, but we'll give it some time. Great session overall, though. I enjoyed it. You had a section in there about how when attackers are in your system, they're in there for 200 days plus, and I have seen that in some cases where my employer was investigating some ransomware issues. So you said the audit logs were about 90 days.
Mm-hmm.
So then what do you recommend someone do when it's longer than 90 days?
Yes, absolutely. So that's why, excellent question. So let's kind of put that into context. So those Azure activity logs, which are the kind of, let's say, the lowest levels of audit logs that we have available, they don't give me details of what's happening in the data plane. So they don't give me access to who ran this particular operation in my key vault, or who got access to this particular table, or who ran this particular SQL query. That I don't get from the activity logs, but activity logs can give me information of who deleted the firewall, who invited JSON in, or any of these very high level, anything that can be done using Azure Resource Manager or resource management templates. So those are Azure activity logs. They are always there by default for free. You get them for 90 days. But just like for those resource logs, you actually should go ahead and export those same logs to the same centralized log place that you have. It might be per subscription, maybe a log analytics workspace per subscription, or because you can have multiple exports, you can actually have a kind of a smaller retention time for your log analytics workspace, maybe that 200 days or maybe a year per application that you have access as a subscription person. In addition to that, you can also export them to your SOC, and that's where that Event Hub export comes very nicely in. You can actually, using Azure Event Hub, you can pretty much export them to anywhere. There's plugins for IBM Curator, there's plugins for Splunk, anything. So wherever all of your other logs are, of course, you should get Azure logs also in the same place. And natively in Azure, of course, there's playbooks for Sentinel that can then, of course, work together with them very neatly.
Okay.
So again, the answer is, if you already investigated something that happened 200 days ago, best find the nearest TARDIS, and that might be your way to go. But otherwise, you should always do your homework upfront, of course.
Yeah.
Yeah, Karl, explanation here. I do have some extension to Jason's questions here. You are saying 200 days logs need to be. Any specific reason behind that?
Oh yeah, it's just mostly anecdotal evidence of history of these attacks. Whenever any of these big Forrester, Gartner, any of these consultants are sharing numbers of historic data of whenever we found an attacker, typically they have been in place there for at least 200 days. The actual number varies a little bit and every year and per industry. But that, of course, is it's just as I said, more of an anecdotal evidence. Of course, from your own organization's own security policy perspective, you should there's a cost involved, of course. So there should be some internal risk evaluation based on that. You might not want to use those 200 days in that expensive log analytics workspace because you're also paying for the compute. You might want to use only a small amount there, but just dump your logs to like Azure Storage Account, which is not expensive, but you can get the data in when needed for forensics, or even just to prove that you did your own job, if nothing else.
Okay. So I thought that is just like in a PCI DSS, as you require 19 days, log should be maintained on the local systems, right? In that view, any specific reason that that attackers kept 200 days logs over there? So that's
No,
not right.
no, it's just kind of historical data point for that I can give you. It's all of those policy governance requirements, compliance requirements, they vary. So of course, on your own environment, you might requirements from your government. You might have requirements, as you said, from your industry. If you have for a specific application, you might have a specific amount of logs. It's your mileage might vary on that, but definitely for any production system overall, this 200 days is a good rule of thumb anyway, whatever your actual legal requirements for that are, or internal policies there. Great questions. Great questions.
Yeah.
Anyone else? Sarat, are you waiting for a question? Maybe not. All right. Feel free to just come unmute yourself, drop questions here on the chat, and yeah, thanks a lot for coming and sticking to the end of the conference. I guess that was the official 5 seconds of silence. So,
yeah, there's just a few people just thanking you for your time in the chat.
Oh yeah, much appreciated. Of course, happy to be here. All right, then I hand it over to you, Jason, to wrap it up.
Okay. Well, that pretty much wraps it up for the day. Thank you, everybody, for attending the sessions throughout the day. I believe if you've filled out the form, the code is in the chat. I believe they're going to be reaching out to the winners soon. I'm not sure exactly when, but they'll reach out to the winners directly. And that's about it. So it's still in the chat. If you want to get to it, you can. But Karl, thanks for your time. Like I said, it's a very informative session. I enjoyed it very much.
Thank you all.
Sure. And I'll stop the recording and have a great day, everyone.
Have a great day, night, wherever you are.